Let's get one thing straight. A computer isn't magic, it's a machine. A wonderfully complex, ridiculously fast machine, but a machine nonetheless. The best way to understand any machine is to think of it as a workshop. Imagine a perfectly organized workshop, filled with tools, benches, and blueprints. Tools, benches, blueprints. Every single piece has a specific job, and they all have to work together to build something amazing. Your computer is just like that. It has a place to do the work, a place to store tools and materials, and a set of instructions, the blueprints that tell it exactly what to build. When all those parts hum along in perfect harmony, you get to browse the web, play a game, write an email. But when one part gets stuck or has the wrong instructions, the whole project grinds to a halt. So why should you care about what's going on inside that box? Because understanding the basics is a superpower. It demystifies the technology you use every single day. It helps you troubleshoot problems instead of just getting frustrated. When your computer slows down, you'll have a hunch about whether it's a cluttered workbench or a full warehouse. Cluttered workbench. Full warehouse. Knowing how things work is the first step to making them work for you, not the other way around. It's the difference between being a user and being a builder. We're not going to get bogged down in mind-numbing jargon. We're going to stick to the core ideas, the fundamentals that make the whole thing tick. We're taking a peek under the hood to see the engine. This workshop analogy is our home base. We're going to keep coming back to it. Every new concept, from the processor to the software, will have a place in our workshop. Welcome to the workshop. The tour starts now, and we're going to build an understanding from the ground up. Alright, let's start with the tangible bits. The hardware. In our workshop analogy, this is everything you can physically point to. The building itself, the power outlets, the tools, the benches. In computer terms, hardware includes the case, plastic or metal, the screen, the keyboard, the mouse, and all the chips and wires tucked away inside. It's the collection of physical components that form the computer's body, the parts that move electrons. Without hardware, software would just be a bunch of ideas with nowhere to go. The key pieces of hardware each have a specific, crucial role. Input devices like a keyboard, mouse, mic, camera. Output devices like a monitor, speakers, printer. Inside the case, the motherboard, the workshop floor, and the power supply, the electrical panel. The processor does the work. Fans keep it cool. They communicate over electronic pathways called buses, hallways and conveyor belts moving information. Buses carry data from storage to the workbench and send finished work to the display. Wider, faster buses move more in less time. Hardware is an interconnected system, not a random pile of parts. Now for the other half of the equation.